So this just arrived in the post today. It's a small kit. So this is a light operated switch, and it came from Banggood in China, and it cost about £2. So I wanted this to switch some LEDs in the garden. So we have printed circuit board with a quite nice silk screen on it to show where the components go. We've got a relay, so that can switch mains at 3 amps. I'm not going to be switching mains, but it's quite useful to have. There's an LDR for sensing the light level. Some various pins and headers. Socket for the IC. The IC, which is a dual comparator, I think. What's that? LM393, so a dual comparator. There's a transistor, a few resistors, a couple of decoupling capacitors, a couple of diodes, and an LED. I think that's the standoff for the LED. So I'll start putting it together. So I think I'll start with the resistors. So this one is 4K7. Okay. I've got a couple of 10Ks here. And 3 1Ks, I think that is. Yep. So next a couple of diodes have to go in here. Make sure to get these the right way round according to the silk screen. I'll put these two little capacitors in as well at the same time. This solder's a bit thick, but it's all I've got at the moment. I'm just waiting for some thinner solder to turn up in the post. Okay, so electrolytic capacitor, that needs to go with the negative on that little white bit on the board, if you can see that. I'll put this LED in as well, which also has to be the right way around. Should be that way. Actually, this standoff might be for the LDR. Might take that off. I think socket, I'll put the socket in, get the cutaway to the top like on the silk screen so I know which way to put the chip in later. Just bend the pins a little bit, make that hold in place. And I'll put this variable resistor in as well. So I think the variable resistor is there to set the level of light or darkness that the switch switches, so it allows you to set the threshold. But we can experiment with that shortly. Oh dear, standing a bit proud actually. Yeah, looks a bit better. Okay, the transistor in. The LDR I think I'm not going to put on the board. I think I'll just run a couple of wires out of the holes here, because I might want to have the LDR in a different place, like stuck to the inside of a window maybe. I don't know, I'll see. I might put this jumper in. Actually, I'll put that one in as well. Let's see. It's going to need a bit of blue tack to hold it in place, or white tack as this is anyway. I think I've got a solder bridge there. Let's just get that out. Right, so I'll put the relay in. It can only go in one way, so this is the power connect where the power wires go in here, the 5 volts. We'll just put some wires in there, I think, and then a couple of jumpers. It's a bit wonky, isn't it? Let's try and push that in a bit more. Yeah, it's better. Whoops. So we need the LDR in there, some power wires, and just plug in the chip, and that's essentially complete. There we go, the LDR's in place, power lead here, and we're ready to test. So the moment of truth for testing. So I've got 5 volts coming from my power supply here. Okay, Here's the LDR. Yeah. So there you go. As it gets darker, the switch comes on, and if I turn this, so this changes the set point where it detects darkness. So there's a bit of reverse engineering you have to do to figure out where the jumpers go. So this jumper over on the right hand side is fitted between 1 and 2, so that enables the relay, and then this jumper over here, so I've got jumper 2 and jumper 4 in place, which is what you need if you want the relay to switch on when it gets darker. And if you put the other 2 jumpers in place, then the switch comes on when it gets lighter. So I've worked out what the circuit diagram is, and I'll put that up on the screen in a moment so you can see what that looks like, because there was no circuit diagram provided with this unit. So to explain this circuit diagram a little bit, up here we've got the 5-volt input, there's a protection diode, and there's some capacitors here to smooth out the DC voltage, and I've labelled that VCC, which is what goes in as the positive rail on the main circuit. So basically here on the left we've got the light detection circuit, in the center we've got the comparator, and then over here we've got the output transistor, and this here is the relay circuit. So this is what switches the relay on and off. So depending on how you have the JP2 set, you either have the LDR on the low side connected to ground and the resistor is connected to VCC, or if you've got JP2 with jumpers 1 and 3 in place, these two are swapped round, so you then have the LDR on the high side. So this means that depending on how you jumper this circuit, you can either detect the light getting less, so getting darker, or you can detect things getting lighter. So basically what we've got here is we've got the comparator, and in the way that I've got it wired here, as it gets darker the resistance of the LDR increases, so this voltage becomes higher, and eventually the voltage on the negative pin of the comparator will be higher than the voltage on the positive pin, and at that time what will happen is this will switch from high to low, so this goes down to the output goes down to 0. So by changing this variable resistor here, you can obviously change this threshold, you can change the detection level. So this is what allows you to decide how dark it should be before the switch comes on. So once the output of the comparator has gone low, what then happens is that some current can flow from the emitter of this PNP transistor. It can flow to the base, which means that this transistor turns on, and some more current can flow through the emitter and collector, and that's what switches on the relay circuit here. So what you've got here is you've got this is the LED that comes on when the circuit comes on. This is the relay coil, so this gets energized when the transistor switches on. And then there's a protection diode here, so that when the relay goes off, any back EMF, any generated current will go around the circuit through the diode here and be dissipated, rather than the current going back through the transistor, which might damage it. So then you have finally got J2 over here, which is well, if you look at the thing itself, so J2 is actually this jumper here where you connect the load that's being switched. So you got the normally closed circuits, sorry, normally open circuits here, and the normally closed here. So some other interesting things about the circuit. So you've got this jumper JP2, which is this one here. So if you remove that jumper, then the relay circuit and the LED is disconnected. So then the collector of this transistor can switch something else, and in fact the collector and the ground comes out as J1, which is this here. So if you wanted to drive something else with this circuit rather than the relay, you can do that. And obviously you've got the JP1 jumpers here, which allow you to decide whether to switch on when it's getting darker or switch on when it's getting lighter. So there's a lot of different ways that you can use this circuit, and for £2 I think that offers really good value. So if you enjoyed seeing me build this circuit and test it, give me a thumbs up, and as ever, thank you for watching.